morning to everybody. It's my pleasure to introduce you our guest, Mr. John Browett, Managing Director of CLPA Europe. Hello, John. Thank you for being here with us.
Hi, Ilaria. Thanks for inviting me.
So, John, let's talk about CLPA, CC-Link Partner Association. What are the advantages that the association offers to its members today, and why should they join?
Yeah, well, really, in terms of technology, the CLPA is the world's leading open industrial Ethernet association. Right now, we're the only organization that offers a technology that combines gigabit bandwidth with time-sensitive networking. So, if you're a device vendor who's looking to develop industry-leading products, then we're clearly the clear choice for working with us to develop products that will therefore be the most competitive in the industry.
Regarding the standard CC-Link IE TSN, we have already talked about it in many videos, but today we have more and more case studies in many industrial sectors of successfully working case studies. If you had to illustrate in brief two cases, which would you choose, and why do you think that these one are particularly significant?
Okay, yeah, you're right. Right now there's probably over 100 different major end users globally who are using CC-Link IE TSN, so there's a lot of very interesting applications out there. But probably two of them. The first one would be there's a company based in Poland called Keller, and Keller makes industrial printing machinery that's used in a wide variety of different industries, everything from like consumer packaged goods all the way to, like, for example, parts for the automotive industry, like dashboards and so on. And so Keller used CC-Link IE TSN as the basis of a machine that combines over 60 different axes of motion control together in a very tightly synchronized way. And this means that their machine is able to produce over 3,000 parts per hour when it's operating. And the other benefit of using CC-Link IE TSN on this machine is that CC-Link IE TSN provides the ability to have a very highly converged network architecture, as we call it. So what that means is you can have all kinds of different network traffic together on the same network, and that means that in the case of Keller, right now they have all kinds of different motion control traffic being handled by the machine on CC-Link IE TSN. But in the future, they're planning to add some capabilities like, for example, maybe machine vision. And this means that when they come to add, like, for example, machine vision cameras in the future, they will be able to use the same network for that video traffic. So therefore, there will be no need to increase the cost of the machine significantly, because the network they already have will be able to handle this additional traffic. So, that's a very significant benefit for them. The other case study I have in mind is in Japan. There's a company called Shashin Kagaku, and Shashin Kagaku is a company who makes what I guess you would formally call additive manufacturing systems, or maybe known more widely as 3D printers. And so they have systems which can produce parts with very fine details. And to do that, again, there's a need for very precise motion control in the machine. But along with that, there's also the need to integrate the general machine functions together into one complete system. By using CC-Link IE TSN in the machine, able to achieve this. So again, they've got multiple precise axes that are being controlled by CC-Link IE TSN, And at the same time, they have all the other different machine functions that are also combined on the same network together. And so basically the benefits that Sheshin Kagaku got out of this in the end was that it made their machine a lot simpler. They didn't have to have multiple networks in the machine, so therefore it was a faster time to market. And also they were able to increase the throughput of the machine tremendously because of the gigabit bandwidth that was available from CC-Link IE TSN. They were able to get a throughput on the machine of about 10 times faster than the systems they had previously. So obviously, this was a very key benefit for them and their customers.
Perfect. And let's say that our readers can also read about many other applications on our special supplement that will be edited with the May edition of Fieldbuster Networks. And this year again, CLPA will be present at SPS Italia 2024 in Parma. And what is the main innovation that you will present at your booth?
Yeah, well, I guess there's going to be two key things that we will be displaying at the fair. So the first one is, the way that we're going to have a demonstration of how CC-Link IE TSN allows multiple kinds of network to be converged together on one network architecture, like we've just been describing. So this means that we're going to have a demonstration of how you can take a system which has got all kinds of real-time control in it, like motion control and I/O and so on. But then we're also going to be combining that with the machine vision system. So therefore you can see how the machine vision traffic, the video frames, can share the same network as that for the real-time control, and yet they don't interfere with each other because of the time-sensitive networking technology that's being used in the network. The second item is another demonstration where we'll be showing how time-sensitive networking allows a very highly deterministic level of control. So the way we're going to be doing that is we have a demonstration where we have two different motion control axes that are synchronized to each other. And when the synchronization is done using time-sensitive networking on CC-Link IE TSN, there's a very high level of synchronization between the axes. But then we also have the ability to show how this operates with other popular industrial Ethernet protocols. And you can very clearly see that when a different kind of technology is used that's not TSN based, the level of synchronization is lost. And basically there isn't really enough synchronization between the axes to demonstrate how this would work in a real application. So, if you extend this to how this might work in real life, say you have, say for example, a high-speed packaging machine, and you have multiple axes that are all tightly synchronized operations that have to happen in a very precise way in relation to each other. But if you don't have that level of synchronization between the different axes, then all kinds of problems will start. There's a potential for parts of the machine maybe getting damaged. Obviously, the products won't be acceptable, and so on. So yeah, we hope that visitors to our booth at the fair will take a notice of these technologies and see how they can deliver valuable benefits to their own systems and machines in the future.
Thank you, John, for being with us, and so see you in Parma.